Luis, let me tell our viewers a little bit about you. Luis Montgomery is a graduate from the University of Illinois at Urbana-Champaign, as am I. Luis is a licensed professional engineer and is a president of 2IM Group. He quickly established the firm as a leader in civil engineering and environmental services, providing innovative practices and projects in sustainable drainage systems. Their experiences include working on Illinois and Chicago Department of Transportation, Illinois State Toll Highway Authority, county, municipal, highway, and roadway projects. Additionally, 2IM has worked with Moshel, is that correct? Did I pronounce it? Moshel of the United Kingdom on various drainage projects, and K Plus LLC on a project in Canada. So you're international.
Trying to be, you know.
Yeah. Good. In addition to highway and roadway improvements, 2IM has designed parking lots and related civil aspects for public and private site developments. So, Luis, welcome. I am so curious to hear your perspective, because from our perspective, it's like the minute you hit ground, break ground, it's like you have to protect, you know, from soil erosion and rainwater management. It's like it's go time, right?
It is. It is. That's very true. You know, the sustainability in civil engineering specifically has been relatively new. You know, back in the day, and I'm talking, you know, as of from 20 years ago before until the Roman times and pre-Roman times, the concept of drainage design was, especially in like the civil environment, was to get that water off the roadway, to make it a safe roadway, and to preserve the pavement, because the Romans figured this out, and lots of other people before the Romans, that if you could get that water off the roadway for these, you know, commercial, you know, roads and what have you, you would preserve that road. You wouldn't get it all muddy. It wouldn't break up the carts. It wouldn't break up. It was easier to maneuver. But over that time, from 2000 or years before and up to about until currently, we still want to get that water off the roadway. But for a long time, we got it from when that water hit the pavement to the water as fast as we can. I mean, that was the engineer mentality. So we got it really quickly off of the world, let's say, the globe. So I don't know if you want to show that first slide, the hydrologic cycle of the natural environment. And it kind of leads to what we do in terms of sustainability. As she's doing that, I'll give a quick brief introduction of 2IM Group. As she says, we're a civil engineering and environmental services firm. We do a lot of work with the public sector they're probably our primary client, including Illinois Tollway and Illinois Department of Transportation. But we're also going into other transportation sectors like aviation and rail. In our environmental services, do a lot of work with wetland delineation and a lot of natural resources and permitting on the environmental side, because stormwater is moving into that environmental world a lot more. They're becoming more one. And then we also do a little bit of environmental engineering, phase 1, phase 2 environmental site assessments to determine the contaminants in ground soils. So as that natural hydrologic cycle slide is popping up, the natural environment used to basically absorb they were acted like sponges, you know, the plants, the trees, the grasses, the groundwater would always take the water initially, and it would then, and very little would actually to run off of the surface. It was sheet flow. A lot of it was captured in the plants, like I say, in the trees. Almost, you know, when in a forested area, only 25–30% of the precipitation would actually run off on surface into the rivers and streams. Most of it would be captured in the trees and then infiltrate into the ground and into the groundwater. And is it coming up, or is it having a hard time?
It's shown. The hydrological cycle is shown on my screen.
Okay.
What do you see?
I just see the folders.
Oh, okay.
The folder with all that other information.
Mm-hmm.
And Okay, well, let's move on to the urban visual, if you don't mind.
Yeah, well, before, let's see, let's give it a minute because I think there's a little bit of a delay, but tell me how did you get into this field and, civil engineering and then into specifically focusing on sustainability?
Oh, well, thanks for asking, Alicia. I got into well, I guess back in high school, I really enjoyed geometry a lot. I mean, I thought it was fun. I liked solving the problems and making the proofs. And if you remember your high school geometry, and so then talking to my father, and he was like, you should think about civil engineering. And I'm also, I'm a history buff as well, and culture buff, and civil engineering has such a mix. If you really get into it, it's got a lot of the history of civilization is civil engineering. How, as I said, how even the Romans and the pre-Romans would drain roads and and create bridges and aqueducts and all these kind of engineering feats, and would make their civilizations thrive and survive throughout the history. And most of the time, it was about changing the built environment, your environment, so that it was actually kind of taking advantage of the natural environment, gravity and what have you, and water,
Mm-hmm.
and getting it from where it was to where you needed. I also liked the idea of when somebody one time told me that the civil engineering industry is kind of like the connective tissue in a body. It's the ligaments and the tendons, and you've got your muscles and your bones, and those are the places we are. That's like your home or your work or your the places where we go for entertainment. But all that connective tissue, all that stuff that connects us, whether it be electricity or water or road, are the ligaments and tendons that connect us all, to connect that society. And I think that's it's just a cool imagery, and very fun to be a part of. Now, fast forward to the where I got into sustainability. I actually lived in London for several years, and there they're an island nation, and they had realized that their groundwater levels were depleting, which is where they get their fresh water, a little bit from the surface. But as you can see, a lot of the water in this hydrologic cycle goes into the groundwater. And groundwater table. And in England and Britain, they pump it up and they consume that water and they store it in reservoirs and what have you, but it's mostly groundwater. But as that groundwater was depleting, they actually noticed, especially along the coastal areas, that the ocean water was actually infiltrating, the salty water was infiltrating into the fresh water of it. So this was, 30, 40 years ago when they started realizing this, and they had to figure out what to do to replenish that groundwater. And as I was saying, if you can go into the urban hydrologic cycle now, the next one. Now do the urban cycle, 95%. Yeah, as I said, only 30% in the natural would run off into the rivers, but most of it would be infiltrated or caught into the trees or into in the landscape. Now 95% runs off in an urban because of all the paved roofs and buildings and no infiltration opportunities, no evaporation opportunities, no catchment opportunities. So this was happening in Britain, and it's happening in all places around the world. And that groundwater is now going down lower, and then so that's a big cause of concern, because most of the world, we're very blessed and lucky to have these Great Lakes at our doorstep. But so we can get our fresh water from there, but most places actually get their fresh water, their drinking water, from the groundwater. At U of I, we get it from groundwater, and I think you remember how hard that water was when we would take showers and stuff like that. It was very difficult to get the soap to work. But so in Britain, they said, we got to change this. And as I was working there, they created this system, and it was kind of a best management practices. They called it SUDS, Sustainable Urban Drainage Systems, SUDS. Okay. And what SUDS was trying to do was trying to take the water cycle, reimagine the water cycle, or get it back to that natural hydraulic cycle, trying to infiltrate it into the ground. So some of the projects we worked on were in this very porous area of chalk. England is very known for its chalk. So we'd create these huge infiltration basins. I mean, big as rooms that you can, multiple rooms, and you'd fill them with porous aggregate, and it would fill in that, and you would be able to infiltrate it and try to recapture all that rainwater from the paved areas, from the roofs, from wherever, and infiltrate it back into the ground. So that's one area for SUDS, for sustainable or best management practices, infiltration, and getting it back into that groundwater and reducing it. And instead of having that 95% of the water run off and enter the water cycle, I mean, enter the rivers very quickly also. I mean, usually within the first half hour, and that's why you get those high fluctuations in your rivers. Also, you go down to base flow, dry weather flow, and then you get a rainfall, and it just zooms up. That's not how it was pre-developed times. It would be, since most of it was going into the infiltrations, the water would rise very, very slowly because most of it was being captured. Like I say, 60–70% was being captured in the runoff. So what do we do now? What are some of the civil tricks to our trade? So if the next slide is the permeable pavers.
So we're coming back across the ocean. So you were inspired.
Oh yes, then I came back to here. Sorry.
You were inspired in London, and then you brought all that knowledge and inspiration and used it, and are using it here, right?
Correct.
And if you could talk about well, here, tell us what this is, what this photo is about. This image.
This is a permeable paver.
Okay.
So as you could see, the open grades, they're not sealed. It's not like concrete or asphalt that's a sealed. So as the water were to land on that, 95%, only 5 or 90–95% would run off. Only 5–10% would actually wet the surface and stay. So now the environment is has to take on 95% of this water that it used to naturally only have to take on, probably 30% of the water, the downstream environment. So one of the things that we do is we put these porous pavement. We still want to drive, we still want to park, we still want to be we need to reinvent this connective tissue, as I say. And so one of it is to allow that water to permeate into the ground table, as I was saying, what we are doing in England. So this open graded permeable pavement is drivable. It's great for parking spots, parking lots, great for lots of uses, very strong, not great for expressways, not great for high velocity roadways, but it could take on a lot of weight, so this would have these.
It feels a lot nicer. It looks a lot nicer.
Oh,
I just imagine when I see these developments of like malls or, strip malls, and then they just pour on the asphalt. Obviously there's a cost issue, but it's like, what is your experience in this area of trying to, have clients use this type of best practice rather than the old, hey, this works, let's just keep using it.
One of the best experiences is what we have to do is thank our the governments, if you will, for requiring this. I mean, there's a lot of requirements now to be more sustainable in terms of urban infrastructure or stormwater infrastructure. Chicago Department of Water Management Regulatory Group has come up with a very, I think, good system to promote and require better stormwater management on site for private developments, for developments beyond the public right of way. Like I said, these are much more difficult to do within the public right of way because you have other issues you have to deal with, including, other utilities that are in there. You have sanitary waters that are there. So you have to kind of pick your battles, if you will. And the best place to do this would be in a parking lot for, I think, a residential home. So the next slide is where we did use this, and I can get a little bit more detailed about it. And that was in Casa Querétaro's, the Resurrection Project it should
Casa
be
Querétaro?
Yeah.
Let's see.
We'll do this one next. Oh.
Which one? You tell me which one it is.
La Casa Querétaro, the Resurrection Project. Do you have that one?
Yeah, just jump to the
Okay.
O'Hare one.
Well, it should maybe,
Yeah.
I don't know if it's right before this or not, but
Yeah, this
we
is
used
in.
this in Casa Querétaro, and what was nice about that is that it did have some contaminated soils underneath it, and we were able to take advantage because they had to take 3 foot of the contaminated soils off site and dispose of it properly. But we were, since that was already an embedded cost in the project, we were able to use porous granular embankment and open graded porous stone to be able to fill that 3 foot void, and we were able to capture a lot of water, or the required water, in that stone, which is, and then we were able to cap it with that nice, pleasant, porous, permeable pavers. Kind of looks like brick, and it really adds some nice character to the house, to the residential development. Now the shot that I have right there, that Northeast Cargo Facility, the one that at the
Okay.
airport, that one is called porous concrete, and that's a little bit more industrial looking, and you can tell that it's very, there's a, it still works really well in terms of allowing the water to infiltrate, but it's not very good for, it's better in like in the parking aisles, as where we've designed it. It's not as good in the drive aisles because of too much turning movement, and it starts breaking up the aggregate on top. But that having that porous aggregate, porous concrete on top, and then having an open graded aggregate underneath it, really allows the water to store in that open aggregate, and then but allows the stormwater to permeate through the concrete instead of being a sealed concrete, which then would sheet flow, run off, and we'd have to collect it in catch basins, and we would just transport that water down to some waters of the U.S. By doing this open graded concrete or the permeable pavers, we really benefit from the allowing that stormwater to get in there from almost from the point where it hits the ground, which is where you really want to go. Of course, like I said, we can't do that everywhere. There's a lot of times on the expressways or whatever. So what do we do in those situations? We go to we want to provide some type of stormwater amenity and stormwater quantity and quality improvements. So we go to the bioswales shot, which is
Okay.
one right after.
While I go to that shot, do you get into urban island effect as well? Do you?
So you can. So the albedo for the concrete is very low. That's perfect right here. So yeah, and obviously adding landscaped areas, it will reduce the heat island effect compared to having asphalt or paved areas, it does help. And it would go towards some of those credits for LEED, but I think in the LEED credit arena or calculations, it's more focused on indoor environment and reducing the impacts of your end of it. It's there's very few LEED credits that are dealt on the civil side, in my opinion. But it's not really the biggest areas of impact in a residential development or in a commercial development. It's a lot more the HVAC, the electricity, those energy costs.
Well, there are a few, but they're really important, because we are talking about water and the rainwater management rather than, trying to imitate this hydrological cycle as closely as possible, just like you explained. I mean, I think that was an awesome explanation that you gave. Hey, I want to give a shout out to Juan Calajorrano, who is watching. Hello, good morning, Juan. Thank you for tuning in.
And he's the one who made the recommendation too. We're, as Alicia said, we're both on the sustainability committee at Hacia, and he's part of that. And he was like, why doesn't Luis help do the civil aspect of healthy environments? And here I am. So thank you, Juan.
Yes, thank you. So here we have an image of the bioswale, which I think is a great image to show and explain. And also if you can connect it to, now when people drive down the highways, you can see the bioswales, right? That, you know,
Correct.
those little dips along the roads are purposeful. And what is their purpose, Luis?
So this is I talked about the porous, the permeable pavers and the porous concrete, and that's at point source. So that's when the water hits the ground. We can kind of let it start absorbing and start that treatment train immediately. But like I said, we can't always do that because we have high velocity roadways that won't be able to take advantage. You know, those systems don't work as well. So we have to go down the stormwater treatment train a little bit further, and we go into the bioswales. And these bioswales are the places where we can start. The water would run off, and in this case, from the roadway on the left-hand side, and then you see that furrow on roadway foreslope. Well, that furrow is it's on contour, so there's no elevation change. So as the water hits that furrow, it starts soaking into that point right there on the left-hand side. And there is our first one. And actually, we do this a lot along the tollway when there's no gutter in kind of rural areas of the Illinois tollway. And what they have found is that it's a perfect place to collect the gross pollutants. And when I mean gross pollutants, I'm talking about the bottles and cans and trash
Oil.
bags. No, well, and bigger stuff, very large, large
I see.
pollutants. And
So you
the
have
oils,
different levels of pollutants, like different.
yes. So gross
Okay.
pollutants are the big stuff that are gross, but that just means because they're so big that they don't they can fall out of the water very easily. And then, as you can see, there's that little dam there's a cut into the forest slope, and that's where the gross pollutants collect. And then there's a little dam that the water has to go over. And by just slowing down that water just a little bit, we can then it starts also taking out some of the suspended pollutants. So then there's pollutants in the water column that are total suspended solids. And then they take out, because they have to go slow. You have to be very slow to get those pollutants out. But the advantage is that, especially if you use vegetation, the vegetation will be a great opportunity to take out some of the oils, like you said, polyaromatic hydrocarbons, PAHs, and some of the metals associated with that. And so they will, because again, they're embedded in the water. So as you slow it down, and then they adhere to soil particles, and as the particles fall out, it really helps that treatment train. So this is the area where this is very advantageous in rural areas along expressways, high velocity, where you can't really use, or you won't be able to use, the porous concrete and the porous asphalt.
So what are some of the IDOT sustainability goals that you can share with us, and like how are they reaching these goals?
So there's I don't know if there's any. A lot of times the goals are self governed. There's not from outside sources. Again, they really don't. The Chicago Department of Water Management, for example, the regulatory group does not have. It's exempt. The public right of way is exempt from the regulations. So a lot of these are volunteer goals and systems in place. And with the tollway and with Illinois Department of Transportation and the city, it's really to try to because those public roadways are very large contributors of the pollutants and water. So they're trying to be a good steward, if you will, but it sometimes isn't. It's hard to quantify it and make somebody, because it does have some huge costs, like buying more land or buying more using more products and more. But it's not that they're against it, it's just that they want to do it wisely.
Okay.
So this is, again, a typical section for a bioswale system on the screen. we, we'll use this in rural areas of the highway. And so if you go to the next slide.
Okay.
So this is now going, so we're at the roadway, and we can go, we take water at the point of, we can take the water at the point of contact. We can take it downstream, but we can also interfere upstream. And this is kind of taking interference. So one of the biggest advantages of trees in forested areas is that they're very good at reducing the amount of runoff into the stormwater system, into that thing. As I said before, grasses in that natural hydrologic cycle, paved areas is 90 to 95% runoff. Graveled areas about 60% runoff. Grasses are around 50% runoff. But forested areas, trees, they end up being about 30% runoff. So at the tollway, where there was an initiative that started in about 2018 to plant 1,000 trees for every year the tollway has been in existence at that time. So it ended up being about 58,000 trees that they wanted to plant throughout the tollway system. And this is also very to combat the heat island effect and the urban tree canopy, to replenish the urban tree canopy. So the intent of this is to try to plant these trees in more urban areas. This slide that we're looking at right here was more an I-90 by Rockford. And you could see these tree plantings that we used, that we did at those locations. So as the water falls and it hits the tree at full grown, it will reduce the amount of water that is actually going to hit the ground significantly, and then obviously run off and contribute to the floodings, and so it's kind of a good stormwater. And then at the same time, the area under these trees are areas that you can reduce mowing, and then that also has some good credits, because mowing, is really tough on the environment, even though you need to stay safe and what have you, and have an open, clear spot so you can see things. But these trees will then reduce that mowing and reduce the amount of stormwater. And then also what we're doing is we're using young saplings to plant the trees. So they're very thin. I mean, very 1 inch or less, I'm sorry, in caliper, in diameter. And the thought is, and there's some studies and research being done, that if you can plant the young trees in large amounts like this you can start growing. As they grow, they're a carbon sequestration. So so all that carbon so it's better to get a young sapling in here and have it be able to go from this point in life to a full mature tree, because you get a lot more opportunity for growth, if you will, get more opportunity for and to get that carbon sequestration. So if you go to the next slide, so these are dense tree planting, and
those are multi-purpose solutions here with the tree plantings. There's rainwater runoff, there's carbon sequestration, and obviously it's oxygen for us, right? So
it's got a lot of checks a lot of boxes. So I like the initiative, I really do, and we were actually selected by the tollway to be the leads for this project, and we're in year 2 of a 6 or 7 year contract to replenish these trees throughout the tollway system. And they want to do it, and they're being good stewards. They're trying to do it in urban areas because, again, that's the other urban tree canopy renewal, because the urban tree canopy helps reduce the heat island effect, and then also kind of pay for our sins, if you will, from the past many years of deforestation that the tollway has gone through. We didn't do a calculation as to how many trees were cut to build the tollway system, but 1,000 trees a year for its life isn't a bad number at all. you know, it's a goal and it's an aspiration. We have to be careful about not being careful with the what they call the clear zone. So you don't want to plant trees that are going to be, you know, hit by a bunch of cars and damage cars and damage people and potentially, you know, lose loss of life.
Mm-hmm.
So you have to get them beyond that clear zone. You have to get them in areas that are going to be able to take and what have you. So a lot of times the interchanges, the infield areas of interchanges work, and a lot of times the you know, it's areas where the right of way gets really wide.
Mm-hmm.
So these are just some details of that. And then the next shot is a picture, I'm hoping, of one of our tree. There it is. So that one I think is a dense tree planting, and you know, see how small they are right there, and hopefully
Right.
they grow to become.
When was this taken?
This is along. I think this is I-90, if I'm not mistaken.
Or when was it? When was it taken?
Oh,
When
the
were
one was
these?
this probably
Uh-huh.
last summer
Okay, so
during
we're
the first.
gonna see how they've grown.
Correct. And we're using native species. We're trying to, and they have to be, but they have to be tolerant to the environment. It's pretty harsh out there. There's still a lot of salt that spray and salt runoff
Right.
because, and salt is a,
Mm-hmm.
you know, it's a lifesaver. So we can't. That's a whole other aspect of the conversation. We want to reduce the salt
Mm-hmm.
and optimize the use of salt. I mean, I think sometimes we just kind of throw salt everywhere, and it's not in a very good uh, location, you know, application rate, but the tollway is doing a good job, and IDOT and everybody are doing better jobs at kind of optimize. And it's also because of cost. I mean, salt is expensive when you buy it in the amounts that they do, and if you can optimize it, you might be able to reduce that amount of salt possible.
Mm-hmm.
Are you seeing me, or am I blank
I'm
now?
not seeing you. You
Uh,
disappeared.
let me see if I can. Uh, I don't know why I'm not getting able to get my camera back on. So I apologize.
It's
But you see Luis
okay.
Montgomery, right?
I see Luis Montgomery.
So let's, if we want to go to the next slide, just, um,
Let's see. What slide was next?
it was before it was,
It was
I,
this shot, and then I
yep,
only had
let's,
10.
okay, let's go to,
Yeah. Juan says that he sees us both. I don't see you. It's
oh,
funny.
well, that's good.
Yeah.
Hello, Juan.
There is a little bit of a delay, but
Oh, okay. But then, well, oh, now I can't show you. If you could see me, I don't think you can because my camera seems to be off. But I am
no.
showing, and I can't get it back on. I don't know why it says. I don't know why this camera just crashed on me.
It's
But
getting a lot
then,
of information this morning. It's like, oh my God, how do I
well, I
get
hope you
civil
guys are
engineering?
enjoying it. It's not just an engineer talking.
No, I
It,
mean, there you've covered a lot of really important points on how to design these healthy environments, how to keep our environments healthy, right? And what does rainwater mean or runoff mean, and the strategies to get there. So I think that that's what this is about, is that we do have the tools and the resources at hand, and every day there's innovation happening, right?
yeah. And so, I mean, in one aspect that I wasn't planning on talking, but you know, the healthy environments, the logo that you guys, I had thought about it, were the beehives, right? The honeycomb beehives is the
Mm-hmm.
logo of the healthy environments that you have. And that is another aspect that we could do. Illinois Department of Transportation is, from what I understand, the largest single landholder in the state of Illinois. All those Illinois state roads, Illinois interstates, expressways all over the state, you know, that are 200 feet wide, and most of it is taken over by the roadway itself, but there's also the beyond the roadway. And what we're doing there is we're planting a lot of native pollinator species, because
Wow, okay.
we need to help the migrating monarch, for example, and we have to help the bees, and we have to help the birds, and those trees also, if when they flower, they'll help pollinate other flowers and species throughout the communities and neighborhood. And also those pollinator species are typically native species with big root systems that again, kept out are like sponges, and they can really capture a lot of that water and let it go into the ground and then capture it at the roots. Which is very important to reintroducing, gaining that natural hydrologic cycle. We want to do it where we can. We want to do it safely, but it is possible to do it safely. It is possible to do it along the roadways. It's possible to do it in urban areas, and so it's not something that we don't have to just turn a blind eye to. And then at the end of the day, it's going to help us. It's going to help replenish groundwater. King County is really reliant on their groundwater for their communities. So, it's going to help replenish their groundwater tables and bring them back up. And like I said, most of the United States, most of the world lives on groundwater. So we need to be able to do that across the world and specifically, where we can in the United States.
Yeah, that's so I mean I enjoyed this conversation because this is what, when we work on a project we hit the ground running with people like you, you're a part of the project team. And so we come to the table early in the process to talk about these strategies. And so, you've brought a lot of really great points, and I'm so happy to hear about the projects that you're working on. And, we may even be working on a project together in the near future.
That'd be great.
And I'm looking forward to that. So Luis, thank you so much for joining. I hope that you guys, like you and your family, are well during this time of COVID. And it's definitely a day-by-day situation for me and my family with 2 young kids, and then you have your kids too. And right before the call, we were like, both talking to our kids and saying, okay, is everything okay? Now shut the door, right?
Cállense.
Silencio. And that's our, it's the uncut version, right?
Yep.
So of what this is. But, everybody is in the same boat. We're all in how have you maintained your mental health and, physical health during this time?
Mental health, I don't know if I have maintained it. I think I've lost it. No, it's just day by day. We have to, work is actually fun. So I gotta admit, I enjoy doing the projects that we're doing. And where we can, I hate to jump back to sustainability real quick, but yeah, we're doing it at O'Hare Airport. I think you're working on a project at O'Hare too, where we want to take all that roof drainage from these proposed satellites and terminals and not have them go through the air side, have them be diverted to land side, so that they can be discharged to the waters of the U.S. in a responsible manner, and not have to go and go through all that air side where you got the glycol from the de-icing agents and all the metals and oils and salt and whatever, all the stuff that's in kerosene or jet A fuel, all over. So if we can do these things responsibly, that'd be great. That's great, and that's kind of what I do.
Well, I'm glad that you brought O'Hare. Brought up O'Hare because O'Hare, they're the first ones who came up with SAM, the Sustainability Airport Manual, and no other airport had done that before. So I'm so proud of that. Like that Chicago ORD or the CDA, right? They set the tone and they raise the bar for airports around the world to look at this and to establish some guidelines. You know what, this matters to us and this is important, it should matter. So, kudos to the Chicago Department of Aviation for putting that together.
Yeah, no, Aaron Frame is the director of sustainability over there, and he's been very good at it. I mean, and they do interest. They have beehives at the airport because of so much of, and they're trying to introduce a lot of natural grasses and species and flowers to be able to promote pollination and all that comes with that. So yeah, it's a great opportunity. It's a big project, and it's good to work with clients. And like I said, I've talked about several clients out here that know the importance and want to work together, even if it's going to cost a little bit more, because there are also costs to not doing it. Just because we don't see that there's the pollutants, from the runoff of these parking lots or anything. They end up in the rivers and waters, and they kill fish, and you get algae blooms and all these other things that you can get. So if you can start, you have to start at the highest point in the treatment train, in the water train, and that's at the point where the ground, when the rain is falling, so that those trees, like I said, or porous concrete. And then, and if you can clean it, you're just going to have a healthier environment downstream and for everybody.
Yes, thank you. Well, thank you once again, Luis, for your time and for sharing your knowledge. Next week, well, this month, we have an excellent lineup of more allied professionals and learning about their strategies for designing healthy environments. But next week, we have Margot Olson. She is a senior project manager for Blinderman Construction, and we're currently working together on a CPS project on LEED V4. And we're going to talk about the contractor's role in green building projects. So please tune in to, next week at 9 a.m. and watch out for this month's lineup. Very, very good. Thank you, everyone. Again,
thank you, Alicia.
Yes. And again, thank you for joining Designing Healthy Environments. My name is Alicia Ponce, founder and principal of AP Monarch. We are architects and sustainability consultants where we design for your health, for Earth, and for all. Have a healthy day, everybody. Thank you.
Hasta luego.
Hasta luego.